Hey there, welcome back. It's episode 10. I'm really excited about today because today we are going to build the logic for the animation of the main monster, the main protagonist in our game. In case you haven't figured it out, we're building something like Centipede circa 1980. And the main protagonist, like I said, is the Centipede. So let's figure out the logic for how it moves. It's a little complicated. In fact, today I want to show you first what the end result will be, because that's probably easier than explaining what we're trying to do. And then I'll show you how we got there. So let's go ahead and take a look. Take a look at the top right of our 2D grid, and you'll see we have a centipede monster coming in. This is modeled after the classic arcade game called Centipede. They have a similar monster in that game. And what it does is it bounces off trees and the edges of the 2D grid. It only requires 3 simple rules to control the motion. So that's what we're going to do today, is create those simple rules. I find it really interesting that a system with simple rules can result in complex motion. So for example, if you shoot one of the centipede segments, it becomes a tree which splits the centipede. That's not an explicit feature, it's just an emergent property of the rules in this system. So I find that interesting. The first thing I want to do is clear a space. I want to make sure there's no trees blocking the entrance of the centipede. So at the top right, and this is in the build trees function, after we build the trees, I'm going to just erase whatever's in the top right. And by erase, I mean set it to a space character. Let's add some comments and clean up a little bit. Grid size, ship coordinates. Here's our grid definition. Fired shots. We'll put our centipede segments here. And we should probably set a length at the top. Might be fun to make this random later. Make it 12 for now. Okay, some of these names are kind of dumb. I don't need a comment like that. And this is pretty obvious. If you have good variable names, then you won't need so many comments. Now we're going to set the sprites up. I don't have the graphics work done, so we're just going to stub it out. The image is going to be the standard icon size. It'll take one slot in our array, our 2D array. And of course we're going to want to be able to move this thing around, so position absolute for the style. And the source, like I said, I don't have it yet, so we'll just set it to empty string for now. I wanted to step away from the code for a minute to talk about a new concept. So far, we've learned about variables and arrays as ways to store information. But there's another construct that's a little bit different. It's called an object. So arrays, they store a list of items, and the way you look them up is by number. So if you have an array and it has apple, banana, cherry in it, you would say, hey, I want item 0 if you want apple. Or if you want cherry, you would say, I want 0, 1, 2, 2, item 2 in my array. So it's indexed or keyed by a number. 2 different ways to say that. An object is like an array, but it's keyed by strings. And you would use it to store different types of information. Sometimes you want more of a list of associations than a list of things. Let's say in your household, there are 3 people, Adam, Bob, and Clarice. And you want to store their ages, which is an association, right? Like Adam is 30. That's an association. Bob is 20, and Clarice is 10. So that's what an object is for storing associations. I just wanted to talk through it in English before we go through it in the code so that you would get it 2 different ways, and maybe you would retain it a little bit better. Anyway, let's go back to the code. Now, if you remember the shots video, we were just storing the x and y coordinates as a pair in an array. So we had a whole bunch of these pairs, and then we'd shove them all into a shots array. So it was an array of arrays. It was a kind of 2D array. And we could do that here, but here for the Centipede segment, we don't just need x and y. We also need to know what direction each piece of the Centipede is going in. So what I'm showing you here is how we would do it if we were going to do it in the same way we did shots, with just x and y. And this is initially how I started building it. And I was thinking, well, the direction can be global. We can have one direction for everything. But then I realized that's really not going to work. So then I built it like this, where I had x and y and direction in this array. So the direction's either -1 for left or 1 for right. But then I was thinking, like, this would work, but it's not real clear what this is. I mean, what if we ended up having 5 things we were tracking? Then it would be a real mess. Let's go ahead and put these into the container array so you can see how the whole thing would have worked. So we have segment 0, 1, and 2 into a Centipede array. So it's an array of arrays. If I expand it, you can see 1, 2, and 3. Okay, so we're going to use something called objects instead, and they're much better for this situation. So instead of a bracket, we're going to use a brace character, which is the squiggly lines. And if you see what we're doing, it's key value pairs. So we say this object has an x property, which is a number, a y property, which is a number, and a direction property. So basically, instead of just having 0, 1, and 2, where we store the data as an array, we use keys. So they're actually describing the data. So now if we put it all together, we still have an array, but it's not an array of arrays, it's an array of objects. And it's very easy to see what's in it now. It's not just 3 numbers, it's descriptors. So how would we get the information out of this construct? So centipede 0 means grab the first segment, and then we can say get the x property. Before we were saying like get centipede 0, 0 or 0, 1. Now we can say get centipede 0x. I think this is a much better way to access the data in this use case. All right, let's create the add centipede function. We don't just need to track x and y coordinates with the centipede segments. We also need to track the direction, which is left or right, -1 and 1. So because we have to track 3 things, I thought an object was a better construct to use than an array of arrays. So we'll have an array of objects. Each object is 1 centipede segment. So for x, we will start it at grid size x plus 1. For y, we'll start it at 0. So this is the top right of the screen. The direction is going to be -1, which is left. So we're initializing all the segments to be in the top right of the screen and to be headed in the left direction. And then we add it to the actual centipede segments array. So again, an array of objects. You could also do it this way, centipede segments.push. We'll talk about that more later. We also need to put it in the grid. So we don't track the direction in the grid, just the location. There we go. Everything inside of the begin and end for loop braces gets repeated. So all of that needs to be repeated in the for loop. All of that that's highlighted. This red thing is telling me there's a problem. It doesn't like that brace there. I wonder why. Oh. Maybe it's because I forgot to add the word function in front of our function declaration. There. What's wrong with this? Oh, I forgot a comma. Might be nicer if we start at grid size x and then go to grid size x plus centipede length instead of starting at 0, and that will let us simplify the rest of the code just a little bit. So now x can be I. We can also just use I here. Alright, so let's test this thing. If we expand the grid, it's blank as usual. We run add centipede. That's our new function. Check the grid again. Look at the top right. Our centipede is out beyond where the rendering occurs. So we can move it in bit by bit into the rendering area. Time to see if we can figure out this move centipede function. Clearly I struggled a bit to come up with the solution, so let's go through it in English, what we would call pseudocode. Okay, so we're definitely going to need a loop. And we don't want to loop over the length of the centipede. We want to loop over the segments that we have. And that's because when we start with a length of 12, some of those segments might get shot out, so there might be only 5 left. So we'll loop over the segments. Okay, the first thing we want to do is clear out the current location of the segment. And then we write at the very end, after we do our logic, we'll write out the new position of the segment in the grid array. So if we can continue moving in the current direction of travel, let's go ahead and do that. That's scenario 1 in our algorithm. So if that doesn't work out, our next scenario is, can we go down? And if that doesn't work out, the next option is, can we reverse our direction or go in the opposite direction? If none of these are true, we're just going to write the C into the grid right back where we erased it from without any movement. Okay, let's put some details in here. Keep in mind, this is just pseudocode. We're not going to run this. This is just for you to understand. So I'm glossing over some of the details here, but it should be pretty accurate. Okay, so what we do is we look at where we're going and we see if it's a space. If it's a space, that means it's empty. We can move into it. We also need to check and make sure that we're not bumping up against the edges of the grid. We need to check the right edge and the left edge, at least in this scenario. The left edge is 0. So if all of these things are true, then we're going to continue in the current direction. So what does that look like? We're going to take the segment X and add the segment direction onto it and assign that back into segment X. So a simpler way to write that would be segment.x plus equals segment.direction. It means the same thing. Now the next case, if any of those conditions are false, we're going to have to go to the next case. And then here we try to go down. So we want to see if we look down, is there an empty space? So we'll leave the X alone, add 1 to the Y, and see if it's a space. We also need to make sure we're not going to exceed the bounds of the grid. But this time, we don't have to check left and right, we just have to check down. Because that's the only direction that we might be exceeding the bounds. Okay, so if all of those conditions are true, then how do we move down? We just need to add 1 to our y coordinate, and we need to reverse the direction. So if you bump into a tree or something, if you can go down, you do, and then you go the other way. So then our last case, if we could not go down, let's make these else ifs. So else if means otherwise in English. So if we could not continue in the current direction and we could not go down, then let's see if we can reverse course and go back in the previous direction. So let's check and see if there's anything blocking the way of the previous direction. So instead of a plus direction here, we do x minus direction. And let's also check and make sure we're not going to bump into the left wall or the right wall. This is the right wall first. Then we'll check the left wall. So what we're going to do in this case is first we're going to reverse the direction, and then we're going to just add the direction onto our x coordinate. Okay, let's put some detail in around how we're going to clear out the C from the grid at the very beginning before we check anything. So the first thing we do, as it says, is just erase what's there at the current position. Then we do all of our logic to figure out what needs to be done. And after that's done, we write the C out, C for centipede segment, write it out at the new position. And that's pretty much it.